So this little section is going to look at one of these fellas here. It's a relay. You can recognise it, I'm sure. If you have a look on here, and we can get it to focus, you can see that this one has a little sort of circuit diagram, and then all of the pins on the bottom of it are labelled. Not so difficult, not so easy rather to see in here, but there we are. It's got 2 ins, 2 outs. The little ones here are the switching current, and the main ones here are the main load that it's controlling. So this might be, say, from starter button to ground, whereas these 2 would be, say, from battery to the starter motor. This is an 80 amp, it's rated as an 80 amp one, so you might find a relay like this on, say, a small capacity 125 50cc bike or scooter starter motor relay. I've rigged up here using the test rig a simple switch which goes into, for this wire, a ground return on this one, and this is a typical connector block for one of these relays, and then over here obviously the 2 main outputs, or input output, for the main switched, which I've got linked up to this multimeter. So if I turn the multimeter onto resistance and I press the continuity button, so it will go beep, I plug the relay into here. It'll only go in one way because of this this one here that's offset in a different direction. Plug in the supply leads. Now when the switch is pressed into on, the moment you see there is no continuity between these 2, the main 2 outputs, but when I press the switch to on, the solenoid inside the relay pulls the contacts closed, and suddenly we go to very low resistance in between the main 2. And that's simply how a relay works. And incidentally, that's the best way to test a relay if you've got one that you don't think works. There's 2 halves to a relay if you want to check whether it works. And you hear the click of the relay. Let's make that go quiet. If you hear the click of the relay, that tells you that it's contacting, but what it doesn't tell you is that in the contacts whether there's any high resistance. So if this has gone all rusty and funged up and corroded in there, then we wouldn't know that for sure just by listening to it go click. Over here somewhere I've got an example of the sort of thing that happens over a period of time. It's dirty and horrible, and you can see sort of green, which is the corrosion of the copper contacts coming through the base unit. Now I've pulled off the outer brown casing for this relay, and you can see the insides of it. Dominant feature is the solenoid, the copper wire wound here, and you can see pressed through on the sort of the armature here that's keeping it is this ferrous core, so that's where the magnetism is going to be felt. And then as we look inside here, you can see that this is a moving contact. So when the switching current comes through here, magnetises the solenoid, it will pull this into contact. It's pretty straightforward. We can see that happen if we pull this back into here. See our meter back in for the main contact resistance. Turn the relay up here like this so that you can see it end on. And when I press the switch, you can see the magnetism drawing the contacts closed. And the contacts closed, you can see the resistance of the main branch dropping to 0. There. That's fun, isn't it? Right, there you go.